The second case of area between curve is using horizontal rectangle and then setting up a dy integral. So in the previous case, which is case 1, so everything is in the yellow box. Let's go over that again. So we have two curves, f of x and then g of x. F is the top curve, g is the bottom curve. And then to find the area between these two curves, I set up a definite integral. X goes from a to b, and then I use the top curve minus the bottom curve, which is f minus g. How do you know f is the top, g is the bottom? First reason is you can see it. The second reason is you use a rectangle. So let's say in this problem I use a rectangle. So the way I set it up is I pick a point anywhere I pick a point on the function f of x, and then another point on the function g of x, and then my next question is what is the distance between these 2 points? Then you will using the y value of f minus the y value of g, right? So let's say at that blue point, the function f, the y value is equals to 5, and then at the same x value, the point that is touching the gx, the y value is equals to 1. Then the distance is 5 minus 1, so you know that the height of the rectangle is equals to 4. That is how you find the height of a rectangle, and that's how we get the idea of top minus the bottom. You cannot use bottom minus top. If you use bottom minus top, 1 minus 5, then the height will be negative. So it must be top minus bottom. The bigger y value, subtract the smaller y value in order to keep the height positive. All right? And then in case 2 is what you are unable to determine the top and the bottom curve. That happens a lot. So let's say in the graph right there, I have two graphs for you. One is XL and the other one is XR. XL is the orange curve, that is the left curve, and then XR is the right curve, which is the blue curve. So if you look at the area bounded by the orange curve, the blue curve, and the y1 and y2, you can see that if you are not able to determine the top and bottom, right? If you draw a rectangle to determine the top and bottom, you will get something like y2 is the top and y1 is the bottom, right? So that is not what we want. We want the rectangle touching the two curves. That is not going to happen in this case. So when that happens, you will have to use the left curve and the right curve. In that case, you will be setting up a dy integral. So how do we figure out the left and right? So first of all, you draw a rectangle. Do you see that there is a red rectangle? And then there is a point on the right curve. There is a point on the left curve. And then what is the distance between them? So let's say, just for example, on the right curve, the point on the right curve is corresponding to x equals to 6. The red point on the left curve is corresponding to x equals to 2. What is the distance between 6 and 2? You use 6 minus 2 equals to 4. Right minus left equals to 4. Then that is the height or the length of the rectangle. You don't use 2 minus 6, right? You want the length to be positive. So 6 minus 2, that is the x value on the right minus the x value on the left. So that's how we get the idea of using the right curve minus the left curve. Because that is how we figure out the length. The length must be positive. And then what about the width? The width is just a delta x. You don't see, oh, this is not supposed to be a delta x, by the way. This is supposed to be a delta y. So let me go ahead and erase that and then change that to a delta y. So that is supposed to be a delta y. And then delta y, you don't see the multiplication right here, but you see this is a dy integral. Why do we have to use a delta y? So let's say we use a 4, right? Times delta y, right minus left times delta y. That is only the area of one rectangle. So this one, depending on the number of test interval you use, this we can do like 4 rectangle or 5 rectangle, right? So the delta y is always the same. Do you still remember the back to the Riemann sum? Let's say the lower limit is 1, the upper limit is 10. Then how do you divide that into 3 intervals? You use 10 minus 1, the max minus min divided by the number of intervals you want. Then you will be able to figure out the width of each interval, which is the y right here. Okay, so I know this is just a concept, but I just simplified everything from the book for you. So if you fully understand this, there is no need to read the book. But to understand better, let's use a simple example. So we have a simple example right here. So this one, I have two parabolas, one on the left, one on the right, but they are x equals to some y. So x is in terms of y. If you are trying to use your graphing calculator to graph these two functions, you will see that the calculator cannot do such work. I never use a graphing calculator to calculate this type of the x equals to some y function. If you know how to do it, write a comment below so other people can see it. But other than graphing calculator, you can use an app called Decimal to graph this. Regarding the Decimal app, I will talk about that after we finish this problem. So let's go back to this problem. So first of all, I have two curves, and then there is a bounded region. What is the area? The area is you use the right curve minus the left curve, right? But how do you know? How do you determine the right and left? So first of all, there are two intersections, one right here and then one right here, right? So this one is clearly x equals to 0, right? In the origin. But what about this one? So to figure out the intersection, because the area is bounded by this y and this y, right? So that's why we have to figure out these two intersection. So to do so, you have to do some algebra. So since they are touching each other at that point, then you will have to set them equal, like y squared minus 4y equals to 2y minus y squared, and then you solve for y. Let's put everything to the left. Y squared plus y minus 4y minus 2y equals to 0. Then you have 2y squared minus 6y equals to 0. Then factor our 2y. Then you have y minus 3 equals to 0. Then 2y equals to 0, and y equals to 3. Not y equals to 3. Y minus 3 equals to 0. This is called zero product property. The zero product property says you have a times b equals to 0. In that case, either a is equals to 0 or b is equals to 0. You use this property only if the other side is equals to 0. If a times b equals to 1, then this is not going to apply. All right, the other side has to be 0. Then y equals to 0, which is right here, and y equals to 3, which is over there. You don't need to figure out the x value because this is a dy integral. The lower limit and upper limit, we use y only. And then which one is the right, which one is the left? Let's go by left and right. So left and right. To figure this out, we have to draw a rectangle, but most people can see it. So let's say we pick a random point anywhere between 0 and 3. So let's say we pick this point. You don't have to pick this point. You can pick a point right here. Okay, it doesn't have to be that point, any point between them. And then draw a straight line. So there is a point on the left curve. So I can see that the right curve is touching the red, the left curve is touching the blue, and then using the midpoint rule, we draw a rectangle. What is the height of this rectangle? The height of this rectangle is you are using this point on the right minus this point on the left, right? So the right curve is going to be 2y minus y squared, and then the left curve is y squared minus 4y. And then now you are able to set up your integral, and they go from y equals to 0 to y equals to 3. So this is the setup you have to do before you draw the integral. Even though you are doing homework online, I highly recommend you to draw the graph. Make sure your graph is nice and big. Label everything, do all the sketch work, and then set up your integral. Don't jump straight to the integral. If you jump straight to the integral, most likely you will make a mistake. So the area is equals to y equals to 0 to y equals to 3. If you're doing homework online, they don't need you to write the y equal. Just write 0 to 3. And then you use the right curve minus the left curve, and then you do a dy integral. So the right curve will be 2y minus y squared, and then the left curve is y squared minus 4y. Do not forget the second parenthesis because you will be doing a distribution. If you don't do these two parentheses, that would be a huge mistake. All right, because you are doing a minus, right minus left, so the second parenthesis matters a lot. So I will just do setup but do not evaluate. So I will just set up the integral for you. So to evaluate this integral, you simplify the like terms, and then you use the simple power rule to integrate, and then you do the fundamental theorem of calculus to find out what that equals to. So that part, I leave that to you, because in this lesson, we will be focusing on setting up the area, setting up the integral to find the area. All right, so before we finish this video, let's take a look at the decimal. So this is what you see in the decimal. So for the decimal, if you are using your phone or a tablet, you can just go to the App Store or Play Store, search decimal, DESMOS, and then this is all completely free. Just download it, and then you will see this page. So on the very left hand side, when you input the function, you usually input y equals to x squared, right? You usually write such input, but you do if you want to do x equals to some y squared, just type x equals to, and then you can type a y squared minus 4y, and then the app will graph that for you. That works in computer too. Just Google decimals. Well, this video is not sponsored by them. That's okay. The other function, you can do x equals to 2y minus y squared. When you reach to the next line right there, they will use a different color for you. All right, and then you will see the intersection. If you just move the cursor or your finger to point at the intersection, they will tell you what the intersection is. But if you are taking a test, especially a written test in class, you have to show your work to find the intersection. That means you have to handle the algebra. So when you do your homework, I strongly recommend you to be prepared to do the algebra to find the intersection. Don't count on the technology. All right, so that's the decimal, completely free. You can use that for your homework, but on the test, especially an in-class test, I am sure you cannot use your phone or your iPad. All right, so that will be the end of this lesson. If you think my video is helpful, let me know in the comment below. Like the video, subscribe to my channel, share the video for me. Appreciate your help. As always, see you all in the next lesson. In the next lesson, I will give you more example of how to do the left curve and the right curve thing. All right, see you all in there. Signing out for now.